And we're back! Welcome to another exciting episode of Awesome Stuff Badly with me, Uncle Dr. Ernie. And this time, it really is exciting. This is the episode that we've been waiting for, that everything else has been the warm-up for. In fact, this is probably the only, or at least the first episode, that anyone will actually watch. Because today is when the magic happens. So if you've been trying to peruse these old videos, you've seen me stumbling around fighting with SVG and CoffeeScript and jQuery and all this stuff just to get a little picture up on a screen. But today, we're going to start dealing with the real magic. The whole reason I started this company and quit my job of 17 years at Apple. Here's the idea. People, when they think of programming, they think of a language. That's the metaphor we use for programming. And that's been an incredibly powerful and useful metaphor, but we've forgotten that it's just a metaphor. You see, what happened was when people invented programming almost 100 years ago by now, they were thinking in terms of trying to recreate natural language. There was this brilliant guy named Chomsky, who's still around, who had done a lot of studies on natural languages. And in the 40s and 50s, when they were developing high-level computer languages, they thought we should really try to grapple with the complexity of human language and all the different syntaxes and parsing it and all sorts of things like that. And this is part of a huge movement known as artificial intelligence, trying to make computers that think like human beings. And it was a brilliant idea. It resulted in lots of amazing stuff, but there were a few problems with that. One, it's not really that easy to simulate a human being. In fact, we don't even really understand what it means to be a human being. And those of us who work in technology are often worse at it than most. The second thing, and this is what I've been researching for the last 4 years that finally drove me to quit Apple to launch this company, language is the wrong metaphor. What we're really after is, I don't even have a good word for it yet, but let's call it a document. I have something I want the computer to do. I want to create a document that tells the computer as easily as possible what it is that I want it to do. I call it document-driven programming, as opposed to the traditional way of language-driven programming. And this concept is at the heart of everything we're doing here in Rohan's Teenage Robot Turtles. And today, we're going to start building that right before your very eyes. So let's get started. Launch my old trusty friend TextMate. And let's start here. Now, the reason I decided to go this direction is I realized I had a problem. The problem was that I couldn't really break out my turtles from the rest of my drawing because all this state about the size and the grid was getting mixed up there, and so I had to include them all in one place. And what I realized was this is where I need to bring in these ideas of document-driven programming. The basic idea is that we have a document that describes the state of the system that we care the most about, and then we have other tools that work around it. Traditional programming, like I studied the structure and interpretation of computer programming at MIT under Abelson and Sussman, two of the giants in our field, and they talked right up front that computer science is not a science and has hardly anything to do with computers. Computer scientists treat computers the way astronomers treat telescopes, loving tools, but not really the focus of investigation. And one consequence of that is that they really thought of themselves as mathematicians. And the whole semantics, the whole concept, the conceptual space that programming was developed in was founded on these ideas from mathematics. And in particular, there's this sense about mathematics as being eternal and immutable. And the purest form of programming is what people call pure functions. And this is the idea that real programs should be like pure mathematical functions that are just eternal and timeless. And things that deal with state, things that change, things that have to be cached and stored and managed, those are impure. That's really the term that they use for this. And I'm a physicist. I love the real world. And, as a Christian, I've been trying to make peace with the idea of the incarnation, that flesh and blood and being human is actually a good thing. That's the other big idea that we're working on in the Swan Factory. And so in document-driven programming, you have mutable state. You have a data structure that changes at the very heart of your program. And all these pure functions that you may create over time are not the heart of programming, they're the edges of programming. The heart is this mutable data structure, which we're going to call a document. And this is both the code and the data as one thing. One of the big decisions that was made very early on in computing, which was a brilliant hack, was called the Von-Neumann architecture. And the goal of that was to split the messy parallel circuitry into a chunk over here that dealt with the code and a chunk over here that dealt with the data. And that the data was one piece over here that was your random access memory, and then your code was over here in a ROM or a fixed program. And that architecture has been phenomenally successful, unbelievably successful for the last 50, 60, however many years it is. But that has a whole bunch of problems. One, it's incredibly inefficient in terms of power consumption. Secondly, it doesn't deal really well with parallelism when you have multiple things going on at once. And third, it creates an awful lot of complexity. Back in the day, it was just, hey, we're just going to have some instructions here. We're going to write these things. But because those instructions threw away a lot of information about the underlying circuits, we ended up having to add all these other layers and instrumentation, all this complexity. So what we're going to do today, right before your very eyes, is start over from scratch and think about how should we really think about computation and how should we build a programming environment. And it's going to take a little while, a couple of weeks, but we're going to do this and you'll find out whether I succeed or not. All right, here we go. So the first thing we're going to look at is creating a bunch of modules that describe this environment we're going to create with. And we'll keep our reactive stuff up there, although I realized I was getting confused about the S dot. I'm going to change that to an SVG. Keep the dot there, thank you. That way I know exactly what's going on there. Because there's not too much going on there, but there's a little bit. Is this actually our main? Yes. Why did I not? Oh, so we have to change that there. Let's just start there. It's a little bit of a digression, but make sure, where are we? What source are we on here? Yes. Let's just get rid of our desktop for future reference in case we need to debug that. There's a lot of stuff that doesn't work. We're going to go with what does work and get the hardest part first and clean up the rest later as we need to. So I'm going to commit this. Okay, and let's go to DDP. What's it? Git -d checkout -b DDP. Okay, so document-driven programming. We start with, what do we start from? And everybody starts with something. We're going to start with a global object domain. The idea is that the core rules for what we build are encoded in this global object domain. And that's what everything else inherits from. And then we create little worlds out of that. So it's going to look something like this. Let's grab some of these. And we are going to call it God or God. Yes, I know. And then what we do is we're going to load a config, which is the specific set of rules for the world that we are creating here. And then we are going to create the world equals God initialized with a config. And then we are going to, so let's get a draw module here. And we probably need to create that with our reactive framework. And then we are going to create our SVG like that, where we basically just going to go draw SVG world. And so that's how this is all going to shake out. It's going to take a little while to make it all work, but this is what the future program is going to look like. Hang with me. You'll see. And for those of you watching in the distant future where I'm a wild success and everyone programs this way, remember at the beginning, it was just me with a crazy idea in my parents' spare bedroom and a laptop believing that it was going to happen. Because that's how you do awesome stuff badly. That's how I do awesome stuff badly, and I believe that you can too. All right? Let's go. Stub modules. Let's touch. Let's see, what do we have here? These are all right. So we're going to go god.coffee, touch raw.coffee, touch config.coffee. And let's comment those out and run this and see what happens. Okay, didn't break anything. Woot, awesome. Let's put that. Let's add dot, cd dot dot, commit dash am, create files. Now let's start wiring these puppies up. And to begin with, let's work backwards just to make life a little more interesting. No, let's go from the beginning. Okay, we are going to make something that's going to look like a model here. So we'll look at this file here as our starting point. And the thing that we're creating here, our actual classes, which are not directly exposed, is a world. And this is going to take a seed. Let's call it a document. And that's going to create a reactive cell around that. We may have to change that later once I get a better understanding. If we didn't, we could just use CoffeeScript's inherent technology to wrap that in there. But a world is built around a document, and I'm going to pass Rx in there explicitly just to make life real simple. And then the thing that we export is actually going to be a function that takes, this does seem a bit redundant, doesn't it? Well, let's just go with it for now. And all right, that's why I'm doing it this way, because I don't want to have to worry about whether things are functions or methods or names like that. I can just have a function and call it, and everything should just magically work. So, and then importantly, let's actually go ahead and create the methods here, because this is really the magic of all this. The theory is that the primary ways that you interact with the world is you can get things and set things. Now, this may seem like a really ridiculously obvious thing, but in traditional computer science, when I learned Scheme from the feet of the masters, setting variables was a no-no. You only created variables when you created the world. Changing it after the fact was something that they pushed off to chapter 23 because it was so impure and evil. In our world, we start with that. We get a, let's call it a path. And then just dub this in there for now. And then you set, you name things. Set path to a value. It's also not implemented yet, but it's something, all right? And this is our global object domain, or our God function that creates the world. And let's just launch this. Shouldn't have done anything much yet, but should be able to, we don't have a config yet, Well, actually, we should. Let's actually run this. Yep, we're still, are we watchifying? Oh, we're not watchifying, are we? That would be awkward. Let's, is there no config module? Oh. Sorry about that. Get the dot. Okay, much better. And does that still run? Yes, okay, haven't broken anything yet. Awesome. And we can get rid of these things because we don't need them anymore. And we'll keep the draw grid for now until we replace with something else. So we're going to get a document from our config file. We will load that in as part of our initial world. And then we want to be able to draw it. And so let's close all these things here and work on that. So, oops, we didn't commit our and I keep checking stuff there. Okay, now we have our world. What we want to do is be able to draw the world from there, which means first we have to, let's go ahead and create our config, which is going to look like not much. So exports -config equals dictionary. Shocking, isn't it? So we'll just have, keep it really simple at first. Let's get the names that we wanted from here. We don't need to namespace it because this is the world already, and it's, I could use a better name for that, but I can't think of anything offhand. Well, let's take a moment and think. So what we want to do is the number of rows, number of columns, and we're assuming a square to make life simple. I actually can't think of a better name than split and size. So we will go with that for now. And then let's check and see if that actually returns what I think it returns. Yes, yes. Okay. And sorry about that. Change that code there to make sure I'm actually looking at it properly. Okay, yes, it is rendering it. And let's see, let's actually open that in a browser. Yes. Check the console. Console. Size and split, woohoo! There's a bunch of little turds in there from our CoffeeScript testing. Let's assume we don't have to worry about that for now. Okay, and now that we have our config object, our config document, rather, we can go in here and make sure that we can get those values. And I really should be writing tests to do all this stuff. But let's build it out now, and then the next session we will do the testing. So if our document is just a dictionary, then it'll just be All right. Doesn't seem like it get much simpler than that, does it? Oh, except that, of course, there should be the local variables there. Again, looks ridiculously simple, and it is. That's kind of the point. Now, there's a little bit of subtlety that later on we have to do some things around inheritance and mutation and policies and stuff. But we start with a really basic, simple idea that programming is about creating this document or this world or document describing a world, if you like, a virtual world, and then we're just going to change properties in there in order to affect this world and affect the state of the computer. This is based on the idea that the fundamental primitive computation is not mathematics. It's something called a stateful switch, the stuff that Claude Shannon, the guy who named the bit, invented way back in the day. And that therefore programming computers is really about setting the states of these switches so they can change the states of other switches. And that's what we're doing. We're basically taking a name and assigning it a value. And that's effectively setting the state of a switch. And if you understand that primitive, then you can build everything else on top of that. That's the theory. You, from the future, will know whether or not I was right. Or maybe if there's even a better model you've come up by then. But this is at least a huge step forward from where we are today, even if it's the wrong step. Okay, next. We have this here. Now we can, let's actually test it here, right? We have this HTML. Let's see. The world is world.get size in pixels in world.get split chunks. So if we have that, we don't actually need a web browser. We should be able to just see it right in our little preview here. Kaboom. Undefined pixel, undefined chunks. Yes, we've got an error. Boot. Okay. Why is that? Well, one thing at a time. rxconfig, rxdoc, at doc. Let's go to JSON method. It just returns the document. Let's make sure we have that. And then it's actually going to be toString. That actually work. Let's see what happens actually. I don't actually remember what the just do that there. What do we get? It's got to be an easy way to do this, but we're not getting that second title there. Are we getting still our libs here? No, we're not. Ah, yes, my bad. Thank you. Okay, that gets seriously confused. What are we doing? Switch element here. Console. No default value. Okay, let's back up a second here. So let's do that first here and see what's going on. Okay, we're getting a world object. That's nice. Document is a source cell. Oh, right. Because the document is a reactive object. So boy, I feel like a total doofus. Find reactive coffee tutorial. How do we actually get the value of a reactive cell? I know I can. Cells. Just get. Right. Okay, good. We will learn something. Because it's a reactive cell, we have to do. Is there a dictionary? Arrays and maps. You can't make a dictionary as a first class reaction object, we just make it as a cell. So we're just going to get the value. Mutated, I think. Well, that's what we're going to find out, right? This could all be completely wrong, and I'll have to do it a different way. Get the document, and let me just make sure I'm doing this correctly. How do we change the value of a cell? There's a cell container for a value. You get set this value. Simple cells, there's a single onset event type. Changes, this value changes. If I want to do a dictionary, oh, okay, no, it is for maps, okay. Define a different array, map transformation of a source array. Objects are called maps. Interesting. I should have known all this, but hey, we're doing awesome stuff badly. You learn it as you go, right, kids? Okay, so what I really want is to create my dictionary from here. So we have the real document is the rx.map, and then this is how clueless I am. Object properties. Oh, CoffeeScript has a better way to do this, right? Object. Thank you for view of doc. Dot put key value. JavaScript uses get and put. Everyone else tends to use get and set. Put does have the value of making it really clear that we are establishing it, but then reactive coffee No, recipe copy is using put, right? Correct? No, cells are set, maps are put. That's interesting. Okay. So putting it there, then we actually are getting I'll go with put. Yeah, it's a significant shift, but in this case, we're trying to go with the idioms we have rather than the idioms we want. So and I wonder if I should just call it key like everyone else is doing and worry about what it means later. Yes. Okay. So we are creating an object or a map, as they call it. We're putting the values into it, and then we can find out all sorts of interesting things about what happens this because it's a reactive document. Yes? Excuse me. Yes. Okay. And back to here. And bring up our inspector and the console. And the world is document, which is the source map. And type error is no meaning value. So if we do any of those names in there? No. So clear. Because that's the source map. Interesting. Oh, maybe because we need to I changes to certain keys, of course, which is nice. We need to be doing real basic things like how do you print out the value of a JavaScript object? Or is that really necessary? Let's just the heck with it. Let's actually go ahead and start using it and worry about making sense of it all later. Okay. So get size, get split. That's the main thing we wanted to do. Let's go back to that. 6 pixels and 8 chunks. Yes, we have successfully stored and retrieved data. Woohoo! Save that puppy. -am. Get values. So, and the reason for all of that is so now we can do draw. So we will go to our draw module. And to start with, we'll just defer to that. But we want us to be able to do draw SVG world and have it basically just do this. Right? How hard could it be? Yeah, right. And exports looks different there for some reason, which is a little worrisome. These will go here. These will be indented. And these will be the values we had from here. Right? Okay, so we have put all our configuration information in the world and broken that into our, oh, that's why it's not, that looks a little bit better, doesn't it? Okay, we call draw grid, we set up this export should be here. And we'll still call all that stuff. Let's see, did it build? Looks like it builds. Let's see if it even runs. Nope, it doesn't. Okay, where do we go wrong? What's there, my man? I'm going to bind. Oh, yes, bind. Must be the binds that tie. Do we need our X to be in here? Or can we not worry about it? Yeah, woohoo! Good, we got a bug. Proof is. All right, so what have we done? We have created our God function. We have put our parameters into a configuration file. We have created the world, and we're able to draw it. Woohoo! I know that may be underwhelming for a lot of you, but this is really where it all begins. By changing the way we think about programming, by breaking up the abstractions in a different direction, we now have a foundation that we can use to build an amazing universe of possibility that is going to turn high-level programming into child's play. Don't believe me? Come back another 10 or 20 episodes later and find out how I have managed to do awesome stuff incredibly badly, and you can too. That's all for this session. Goodbye!